Hello everyone, today we'll be going over and explaining an interrupt service routine, or ISR for short. In previous videos we discussed what are interrupts and how in operating systems we define and gave examples of what they might do. In this video we break down what an interrupt service routine, or for short ISR, is, and just how it is performed in an operating system and its connection with interrupts. So our next topic is, what is an interrupt service routine? Well, the main purpose of an interrupt service routine is to handle events that require immediate attention without waiting for the main program loop to check for them. So instead of constantly pulling for an event, the CPU can continue executing tasks until an interrupt occurs, at which point the ISR takes over momentarily. And this helps because it can use efficient CPU utilization, so instead of continuously checking for events, the CPU can focus on executing other tasks until an interrupt is triggered. And next we have is that it has a fast response time, meaning that the critical tasks like reading sensor data or managing network can be executed immediately without delay. And we also have real-time processing, which means that in embedded systems and real-time applications, ISRs ensure that time-sensitive operations like motor control and data are handled precisely when needed. And lastly, we also have device communications, which basically means that the ISRs help process external device inputs like a keyboard, and it's efficiently by responding to the events as they happen. So our next topic is the structure of an ISR. So an interrupt service routine follows a structured process to handle interrupts efficiently. It is designed to be minimal and execute quickly to prevent system slowdowns or conflicts. So basically this means that the general structure involves saving the current state, executing the necessary task, and restoring execution. So some key points are that it can interrupt, trigger, and context saving. So when an interrupt occurs, the CPU saves the current execution state. So it basically means it registers, it'll flag it, or a program counter to ensure a smooth return after the ISR finishes. Next is we have a task execution. This means that the ISR performs the required actions such as reading sensor data or handling input from a device. And next we have is interrupt clearing and return. So the ISR acknowledges or clears the interrupt flag and restores the saved execution state before resuming a normal program flow. And so this next topic coincides with our previous one, and it's basically the ISR actions. So when an interrupt occurs, the ISR takes control of the CPU and executes a specific set of actions to handle the event. These actions ensure that the interrupt is properly managed and that the system can resume normal operation without issues. And so our points here is that it has a save, processor context, which basically means that the CPU registers and the program counter are stored to ensure that the interrupted task can resume correctly. And we have also the ability to execute the interrupt task, which basically means that the ISR performs the necessary operations such as processing input, handling errors, or updating the system states. And lastly, we also can acknowledge and clear the interrupts. So the ISR signals the hardware that the interrupt has been handled and restores the saved context before. So our next topic is challenges in the ISRs. So writing efficient and reliable ISRs can be challenging because they need to be fast, they need to be minimal, and they need to be free from errors that could disrupt system performance. So a poorly designed ISR can lead to system crashes, slowdowns, or unpredictable behavior. And some key points are that the execution time constraints. So this basically means that the ISR must run quickly to avoid delaying other tasks, as long execution times can block critical operations. And next we have is avoiding shared resources conflicts. So if an ISR accesses shared memory or variables, race conditions can occur, leading to an inconsistent data or crashes from it. And then lastly, we have blocking operations. This means that the ISR cannot use functions like delay or complex loops, since they must return control to the main program as soon as possible. Okay, and with that, we have come to the end of our video. I want to thank you for watching. Please feel free to like, comment, share, and subscribe. Hopefully this helped you a little bit about, interrupt service routines and just exactly what they are and what they do. So have a good one. Thank you for watching.